The first speaker of this next session is Lukas Bertschinger from Switzerland, and he will deal with the matters on environmental friendly and safer ways to produce top quality fruit. So please.
So my task is it to talk about environmental friendly and safer ways to produce quality fruits. Many people have contributed to this. Greg Dorojowski, he's a work package leader in Isofruit, he's among us. Mimo Costa, he's also among us. And Esther Brawin, she's also somewhere. Where is she? Hello. So it's really their work that I'm going to present. Now, what we aim at is actually at an improved quality management in the orchard. So we want to contribute to an increase in fruit consumption by an improved fruit quality, and this by an improved orchard management. So we are now really in the pre-harvest sector of Isofruit. What are the principal themes, issues on which we work and which we will talk about today? Spray application techniques, quality management in the field, for example by thinning, and farm economics. Now, by working on these three focuses, we intend to contribute to a healthy environment and a safer fruit. And in addition to this, the technology developed should be economical, feasible for the growers. Let's go to the spray application technology, and this will be the real focus of my talk. In the afternoon, you're going to hear more about the other aspects. We must be aware that there is a framework directive on sustainable use of pesticides in the European Union, and it focuses on a sustainable use of pesticides, and there an important element is actually the spraying of pesticides. There is a low drift that is required, and for instance, the surface water should not be contaminated. Within 2 years after entry into force of the directive, we should guarantee that in the case of use of pesticide close to water bodies, the pesticide is not dangerous for aquatic organisms, and the sprayer is performing so that water it cannot be contaminated. So possibly, I would say, with the actual spraying technology, this is in many cases difficult to achieve this aim. So there is a need for an improvement of the spray technology. Of course, there are also other issues or cases where this would be useful. You know, the possibly many fruit growing zones in Europe. For example, very small structured area like South Tyrol or Switzerland, where you have orchards close to schools. So also there, or apartment areas. So also there, a reduced drift would be very helpful. Now the CASA system, this is the Isofruit Crop Adapted Spray Application System. And it consists in three elements: the crop health sensor, the crop identification system, and the environmentally dependent application system. And you're going to hear more about this. So the crop health sensor focuses on the health of the tree. The crop identification system looks at the tree as a whole, and the EIDA system is a system that wants to assure that there is no drift or drastically reduced drift, that we can achieve the aims of the regulation that I just mentioned to you. And this should be put together and controlled, integrally controlled, mounted on the tractor and the spray application devices. Now, where are we with regard to the development of this system? we aim with that at the reduced pesticide input into the environment, a reduced drift and reduced residues, of course. And I want to tell you first something about the crop health sensor. So the crop health sensor makes a spectral analysis for the identification of the properties of the leaf. And in that case, the infection is the the issue of the leaf. So there is a technology looking at the spectrum of the light that is being absorbed and transmitted and reflected, which comes onto the leaf. And the spectrum is then analyzed, and if you look at this figure on the right side, let's see, where's the pointer? Here we go. So there, you would not see that from where you're sitting, but if you beam that up, you see a difference here in the spectrum between a plant which is okay and another one which is stressed. So those kind of differences are looked at by this analysis and are the fundament actually of this crop health sensor. You also see the wavelength which is analyzed actually. Now, I lack the time for going to the details, and Greg Dorozhowski would certainly be able to answer any questions on that. But what we have seen up to now is there is a possibility of, in the case of scab, apple scab for instance, that we can detect infection 4 hours after infection. And in that case, as compared to the visible detection, which normally takes about 10 days, this should be a major breakthrough and advantage. The potential opportunities for disease and pest control based on the crop health sensor, or the status determined by the crop health sensor, would be that you can detect the detection of the plant stress in an early stage. You can determine crop vitality. You obtain guidance for supporting the tree against its fight against diseases and pests. You can produce plant health status maps with GPS systems. You can determine dose and timing of plant protection products, applications, and you can also relate this information to the volume of spray which is put into the environment, onto the tree, according to the required protection level actually that you're looking at. So that's the potential of this sensor, and the sensor is now working, but still some fine-tuning, a lot of fine-tuning work needs to be done. Let me tell you something about the crop identification system. So that's the second element in this CASA system. There are 3 elements, we are at the second now. So this system is about the identification of the plant size and the plant density. So there are, if you look here at the tractor and a schematic representation of the sprayer, here there is a tree. There are 3 sensors with piezoelectric elements that look at the different tree sectors. So those ultrasonic sensors identify canopy width and foliage density. And this information is linked with the sprayer information, where you have the nozzles. And this situation is actually, this type of sprayer exists already and is under testing in practical orchards.